Welcome, guys. So today we are solving the Math GRE subject section, which I think this is the most difficult one in this test. It's number 62. Okay, so because this is topology, so maybe probably you guys and me are already forget about all the topology in undergrad. Okay. So the problem is complicated. So R is a set of real lines, but now we have a new topology. This new topology means that since that with the topology generated by the basis, with this is called a half open interval, and this is a basis. And they ask about X is a subset of 0, 1. F is a subset 0, 1 of R. Which of the following must be true? It's a subset 0, 1 of R. So I guess what it says is it's X is a subset 0, 1. I say X is 0, 1. And which of following must be true? So maybe you already forget about what you mean by basis. So in a topology to define a topology, we need to say which one is an open set, which guy is an open set. So this half open interval means that the union of open interval is the open set. So basically, any open set is in this topology is defined to be the union of the half open interval union. Okay, so that means this one is open, and this one is open, and any union of this kind of half open interval is open. This is so-called open set. Okay. Oh, it's very tricky. Okay. So the first one says that X is compact. Okay. So remember that this is not a normal topology. So closed and bound will not imply compact. So you need to go back to the definition. So we need to go back to definition. Definition is that X is compact if any open covering has finite subcover. Well, we need to go back to the definition. So Q1 is 0, 1 compact in this topology. Okay, and the answer is no. Right. This is hard to see, but let me show you. Because I can write the open set 0 and 1. I can use I can use this open interval to cover it. So basically, I can write down it as union of maybe 0, 1 minus 1 over n. This is sorry. It fails. Oh. Okay, so from maybe from 1 to 2. Maybe I change the color. Okay, maybe I close the Chrome to make it faster. N equal to 2 to infinity. So basically, this is over, or I can write. So basically, this is 0 half union 0 1/3, union 0 3/4, and keep union. But now 1 is not in here, right? So I need to cover something, but I just need to do the covering. So need not to be equal, right? Right. So this cover this is open cover, right? However, no finite subcover, right? So to get the finite subcover, I must get this one, because this is the one which contains 1. But this is 1 minus n. So if I get some finite subcover, there will be some large n. But after that large n, so after that large n knots, then 1 minus 1 over n knots. Suppose I get a finite subcover of this, then there must be the largest n knots I get. So this 1 minus n knots and 1. This number x cannot be covered in this region. It cannot be covered by the choice which I take. So from this point of view, it is definitely the open cover, but not the sub. But there's no finite subcover, so X is not compact. Okay, and the second one is say that X is Hausdorff. Okay, so maybe you guys can already forget about Hausdorff. Hausdorff means for any distinct points in the topological space X, there exists the UV open and the U intersection V is closed, can separate this. Suppose you can find a U and V, this is open, then you can separate this. This is called Hausdorff. Okay, now I claim R's any subset in this, basically in this topology is Hausdorff. And the reason is simple enough, because once you have X and Y, then how do you use this? How do you use two open intervals to cover them? No matter how close X and Y, there's still some distance, right? So basically you can use a very small distance to cover it. You can use this two small half interval to cover it, and you can use this open interval to the length of the open interval smaller than half of the distance. Then you can use two open interval to separate. So this is the Hausdorff. And the third one is the true difficulty. Third one asks you about whether 0 or 1 is connected or not. So what do we mean about connect? So X is connected, or X is disconnected if X can be written as two union of some set, which A closure intersection of B is empty and B intersection A, B closure intersection is empty, and A, B are non-empty. Then this is called disconnected. And for the total the total space X, usually we can say that A, B are taken to be open set. But in general, AB cannot be. AB can choose not be open. Just separate. Just satisfy this condition is still okay. So this is called X disconnected. If you cannot find A and B satisfy this property, then X is called connected. So 0, 1 connected. Okay, and the answer is no. How do we show this? How do we do this? So basically, I can write it as I want to write it as 2 union, right? 2 union of. So usually it's difficult, but I can write it as somehow this one, the same as this one. But now I only contains 1 point. Okay, so the problem is that how do I show this to satisfy the property I have? So in order to do this, we need to know some fact. So one fact is that the singleton is closed. I think this is obvious, right? Because if you only take any 1 point out, then the rest of it, the rest of sets for any point you can use a small open half interval to cover it. So you know the complement is open. So basically this is closed. So this is closed means the closure of one is just one. Okay. How about this one? So the problem is, what is the closure of 0, 1 in this topology? So important fact is that when a usual topology, you take a limit points. So the half interval 0, 1 will be the closed interval 0, 1. But in this type of topology, 0, 1 is open. But actually 0, 1 is also closed. Okay, so I would show that I claim 0, 1 is closed. So 0, 1 is both open and closed in this strange topology. And the reason is so to prove this is closed, we need to prove its complement is open. So what is this complement? It's minus infinity to 0 and the union 1 to infinity. Also, this is open, right? Definition. This is open. How about this? This infinite and 0, basically you are from 0 to infinite. Can I use the open interval to cover it? Definitely I can, right? I can use this open interval, this open interval, this open interval. Keep doing to cover it. So basically this can be covered by I will use this. Maybe okay. I think so. From n equals 0 to infinity. So this is open. This is also basically I can cover it by -1, 0, union, -2, -1, union, -3, -2, union. So this is open. This is open. So the complement for this is open. So this means 0, 1 is closed. This tells you that the closure of this guy is this guy itself. Is this guy itself. So that means that the A closure is A, B closure is B, and the A, B are not, and there is no intersection for A and B, and the A, B are not empty. So this is A, this is B, so A, B are not empty. So this shows that you can separate 0, 1 closed interval into two different two sets, which satisfy the disconnectivity. So this tells you that the 0, 1 is not connected. So only the second one, Hausdorff is correct. So the answer is B. So this problem is difficult, and some detail which I don't really illustrate in the video because there are so much strange things can happen in this type of topology. Basically, you can prove that the only connected set in this type of topology in this type of topology is a singleton. And I will probably leave the proof below for you guys if you're interested. And finally, be sure to subscribe to my channel. Thank you.